Listen up, brothers. Look, as engineers installing and operating UPW pure water filtration systems, pure water is absolutely our bread and butter, right? But today, we're diving into a critical explainer on the other side of the facility. We're talking about identifying and mitigating organic shock loads and sudden pH variations. If you're on the floor running the biological industrial wastewater side right alongside our pure water trek, you already know that a sudden spike in COD or a severe crash in pH, yeah, that can literally be your worst nightmare. So today, I'm going to give you the exact blueprint to protect your plant from a catastrophic failure. Here's the blueprint we're covering today. 1. System threats and impact zones. 2. Spotting the early warning signs. 3. Diagnosing the root causes. 4. The 5-step investigation process. 5. Emergency scenarios and action plans. And finally, number 6, long-term prevention and review. Let's get right into it. All right, Section 1, System Threats and Impact Zones. Let's understand exactly what happens to the anatomy of our system when it gets hit. So let's define the enemy here. An organic shock load is basically when your influent COD or BOD5 suddenly blasts past 150% of your design capacity. Or it's this massive chemical wave where your pH just wildly fluctuates entirely outside that safe 6.0 to 9.0 zone. When we see COD spike past that 150% mark, or, God forbid, the pH drops below 6, our biological balance is totally destroyed. And from that exact second, the clock is ticking on the entire operation. This timeline right here, this brilliantly illustrates the path of destruction across your facility. Look at pretreatment. You only got about 15 to 30 minutes to even notice the change in chemical consumption. And notice how we only have 1 to 4 hours before the aero tank goes into critical failure. If you miss that, within 4 to 8 hours, you're pumping out highly contaminated water and looking at some incredibly severe environmental fines. Now, the visual reality of a crash is this thick, dark brown foam. Honestly, it is your absolute worst enemy. When you see this creeping up on your aeration tank, it means your dissolved oxygen is totally crashing, and your essential microorganisms, the bugs doing all the actual heavy lifting for us, they're dying off rapidly, and all that dead sludge is just floating right to the top. It's a complete biological collapse. Moving on to Section 2, spotting the early warning signs. To protect the system, you brothers on the floor really need to spot these symptoms early. You've got to trust your own senses before you even look at a SCADA screen. If you walk in and smell strong chemical solvents, or you see this unusual black or green water at the inlet, stop and check your online sensors immediately. A higher than normal temperature or a really pungent odor means a shock is entering the pretreatment phase right then and there. Literally, every single minute counts here. So, the crucial point here is, if you walk over to your secondary clarifier and you actually see clumps of yellowish-brown sludge washing over the weir into the clean water channel, man, the shock has already blown right through your primary defenses. Your suspended solids are spiking out of control, and at this stage, you aren't preventing a crisis anymore. You are actively in full-blown damage control. Which brings us to Section 3, diagnosing the root causes. Let's figure out where these shocks actually start so we can stop them. More often than not, the culprit comes straight from the production floor. We're talking about an unannounced factory washdown right during a shift change, maybe a sudden tweak in production chemical formulas, or just a raw chemical spill making its way directly into the floor drains. These external sources hit us hard and fast, and usually there's absolutely zero warning from factory management. But hey, sometimes it's on us, right? If you, as the operator, let the equalization tank drop way too low, you just completely lost your buffer volume. Without that massive volume of water to dilute an incoming spike, the shock goes straight to the bugs in the aero tank with devastating concentration. Poor level management can literally turn a minor spill into a major plant shutdown. And we've also got some massive blind spots when it comes to equipment failure. If your SCADA system drops its connection, or say your online pH sensors get fouled up and drift by more than 10%, your alarms are going to fail you entirely. You could be taking a massive acid hit, and your control screens will just sit there telling you everything is perfectly fine. Scary stuff. All right, Section 4, the 5-step investigation process. Let's look at how to find that root cause incredibly fast. You've got to follow this 5-step checklist from the outside in. First, pull the SCADA data for the last 48 hours. Second, grab your bottles and take parallel samples at 4 key points across the plant. Third, go interview the production supervisor. Find out exactly what they dumped down the drain. Fourth,
physically inspect your online sensors and dosing pumps. And fifth, calculate your actual tank capacity.
Speaking of capacity, I need you to calculate the hydraulic retention time, or HRT. It's basically your tank volume divided by the average flow rate. Listen, if your actual HRT drops below 50% of the design volume, that tank simply cannot protect the plant. You just do not have the dilution power you need to strip the edge off an incoming chemical wave. Now we're on to Section 5, Emergency Scenarios and Action Plans. This is all about the first 30 minutes. Ask yourself this. If a massive acid spill hits from the factory and your influent pH suddenly drops below 5.5, what is your immediate response to save the biomass? Because let me tell you, at that pH, your microorganisms are practically burning alive. You must instantly manually override the dosing pumps to push base chemicals like sodium hydroxide. Crank up the mixing in the equalization tank to its absolute maximum to spread that chemical out fast. If the pH rockets above 11, completely cut the influent flow. Keep your dissolved oxygen above 2.0 and take samples every 15 minutes like clockwork until that tank stabilizes between 6.5 and 7.5. Okay, but what do you do when an organic shock load hits? Say they dump massive amounts of solvents or organics into your system, essentially trying to suffocate your aeration tank by spiking the COD up to 300%. First rule of thumb, always stabilize your pH before your COD, simply because the bugs are highly sensitive to acid. Next, slash the incoming flow by up to 70%. Then, max out your blowers to push your dissolved oxygen up to 3.5 milligrams per liter, and aggressively return your sludge, maximizing your RAS to 100%, just to keep your biomass concentrations as high as possible. You need a huge army of bugs to eat that sudden influx of food. Finally, Section 6, Long-Term Prevention and Review. Because surviving a shock is good, but preventing it, that's how we run a world-class operation. So the crucial takeaway here is you've got to push management for serious capital upgrades. Your equalization tank is the absolute heart of prevention. You must demand a minimum HRT of 8 to 12 hours. Furthermore, you really need automated emergency shutoff valves that trip the absolute millisecond the pH goes out of bounds. Because relying on an operator to sprint over and manually spin a wheel, yeah, that's just a recipe for disaster. On the administrative side, we absolutely must enforce a digital discharge registration system. This legally requires the factory to give a 4-hour notice before dumping any unusual loads. And look, it goes way beyond just hanging some laminated checklists on the wall. You need to run these emergency drills with your team every 6 months to ensure everyone knows their exact role the second those alarms sound. I'll leave you with this final provocative thought. The golden window to save your facility from a severe chemical or organic shock is just 30 minutes. That's it. So take a hard look at your plant today. Are your sensors actually calibrated? Do you have enough buffer volume? And most importantly, whether you're managing UPW pure water systems or running the biological tanks, are your brothers on the floor actually ready to act decisively? Equip yourselves, stay vigilant, and thanks for joining me on this explainer. See you next time.